Hi, my name is Sydney Tuttle, and this is my Lab 3 black hole. The purpose of this lab was to create a model in GlowScript that determines the mass of a black hole using the mass and motion of a star orbiting that black hole. I was given a starter code and a black hole with a star orbiting it with the mass of 2.0 times 10 to the 30 kilograms, with the assumptions that the only force acting on the star is gravity and the black hole is located at the origin. I had to make a computational model in GlowScript to calculate the trajectory, path, and forces of the star, and then use those to calculate the mass of the black hole using Newton's law of gravitation. In order to complete this task, I had to use different physics principles, such as the momentum principle, which states that the momentum equals the mass times the velocity, and Newton's second law, which states that the force equals the mass times change in velocity over change in time. In addition, I used Newton's law of gravitation, which states that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers, where g is the universal constant. The first step in completing my GlowScript and computational model was to plug in the given parameters, which was g equals 6.7 times 10 to the negative 11 as the gravitational constant, the mass of my star as 2.0 times 10 to the 30 kilograms, and delta t as the time of 1 day. We were given V initial and V final, but I needed to calculate P initial and P final using the momentum principle and Newton's second law. I multiplied the star mass times V initial and the star mass times V final to find the initial momentum and the final momentum. From there, I found the change in velocity and the change in momentum. This was done using the final velocity minus the initial velocity to give us delta V, and the final momentum minus the initial momentum to give us delta P. Then I used those values to calculate my dp dt, which is delta P over delta T, and to calculate the F net. Since Newton's second law states that the net forces are equal to the change in momentum over change in time, and dp dt is the change in momentum over the change in time, F net is equal to dp dt. From there, I needed to calculate dp dt parallel. Using p hat, which is the p initial over the magnitude of p initial, and d magnitude of p over dt, which is the magnitude of p final minus p initial over delta t, I could find dp dt parallel, which is a known formula that states d magnitude p over dt times p hat is equal to it. Because F net in the parallel is equal to dp dt in the parallel, I could set F net par equal to dp dt par. We know that dp dt equals its dp dt parallel plus the dp dt perpendicular. This means that I could set dp dt perpendicular equal to dp dt minus dp dt parallel, because we have already found dp dt and dp dt parallel. We know that dp dt in the perpendicular is equal to the F net in the perpendicular, so we could set F net perp equal to dp dt perp. This makes sense because the sum of all forces is equal to F net in the parallel plus F net in the perpendicular. From there, I broke down Newton's law of gravitation and I rearranged it to solve for the mass of the black hole. I took r squared and I changed it to r and set it equal to the magnitude of the star position minus the origin position squared. Then I found the mass of the black hole using the magnitude of F net times r divided by g times the star mass. This is simply Newton's law of gravitation rearranged. I coded the GlowScript so that it would print the black hole mass as the code progressed. You can see my finished code here, with the black hole as the black circle, the star as the yellow circle, the trajectory as the green circle, the F net parallel as the pink arrow, the F net perpendicular as the blue cyan arrow, and the F net as the orange arrow. My black hole mass turned out to be 1.4 times 10 to the 34 kilograms. My F net forces were 9.9 times 10 to the 28, and my F net parallel forces were 3.59 times 10 to the 28, and my F net perpendicular forces were 9.2 times 10 to the 28. Overall, F net causes a change in momentum. F net parallel causes the object to speed up or slow down. F net perpendicular is the force pointing inward toward the black hole. and both are caused by the black hole. The momentum is the rate of change for speed in the parallel and the motion perpendicular. If my black hole was replaced with a different black hole, but the mass of the star and the gravitational force stay the same, and the motion of the star stay the same, then the mass of the black hole must be the same. This is due to Newton's law of gravitation.